Welcome to the lecture on review of probability. Review of probability. Okay. In this concept, I'm going to cover the topics, experiments, and sample space regarding events, event and various types of events. Then I'm going to define and explain what is probability. Then I'll explain joint probability. Next, conditional probability. Next, total probability. Next, Bayes theorem. Okay, so these are the concepts under review of probability. Okay, let me start the first one, experiments and sample spaces. Let me define this sample space using the word experiment. The set of all possible outcomes in any given experiment is called the sample space. What is sample space? Set of all possible outcomes in a given experiment. In a given experiment. Okay, so that is called sample space. Set of all possible outcomes in a given experiment. Sample space is denoted by S. Okay, and the sample space is universal set, is called universal set. What is the reason? What is meant by universal set? In my previous video I explained. Universal set consists of all the elements. The same way here, sample space consists of set of all possible outcomes in a given experiment. That is the reason sample space is called universal set. Okay, how to understand? I'll tell you an example. Suppose take tossing a coin. So what is this? Tossing a coin is an experiment. What are the outcomes? What are the outcomes? For tossing the coin, you're going to get two outcomes, head H and tail T. So how to represent the sample space? Yes, is H comma T. This is the representation of sample space. Take another example. This is example 1 and take another example 2. die is an experiment. What are the outcomes? The outcomes are 1, 2, 3, 4, 5, 6. So totally this is called your sample space. Okay, so set of all possible outcomes in a given experiment is called sample space, and as it consists of total elements, it is also called universal set. Then, what is discrete sample space? Discrete sample space. A sample space is said to be discrete if the elements are finite set of elements. Finite set. If the elements are included in finite set, means like this. These two. If S is like this, 1, 2, 3, 4, 5, 6. Then if you see, the set is finite and the numbers are discrete. So this type of sample space is called discrete sample space. Then if you go for continuous sample space, so continuous sample space means if a sample space contains continuous values with infinite number of elements within a given range. Let me tell you an example. Suppose S is like this, 0 less than S less than or equal to 12. Take this sample space. It has infinite number of values. The sample space has infinite number of values between 0 and 12. Because suppose take between 1 and 2. Between 1 and 2 how many values are there? You can choose infinite number of elements. Between 1 and 2. There is no limit for them. So this type of sample space is called continuous sample space. Okay. So totally what are the concepts under experiment and sample space? Definition of sample space, okay, and the discrete sample space and continuous sample space. Now coming to the next concept, events. Events. What is an event? Event is defined as subset of sample space. Event is a subset of sample space. Means what is event? See, what is sample space actually? Sample space is universal set. Okay. It consists of all the elements. So if I say event is a subset of universal set, then event is called set. Simply. Event is called set. Okay. Let me explain exactly what is the real meaning of event. Okay. Tossing a coin. Tossing a coin is an event. Tossing a coin is an event. And what are the outcomes of this event? Either you're going to get head or tail. Tossing a coin and the outcomes, your universal set consists of all the possible things of an experiment. Your experiment totally consists of event and outcomes. Your universal set consists of all the details of your experiment. So tossing a coin becomes a subset of universal set. Because suppose take this example, your universal set consists of this event and outcomes. So simply if you take event, it becomes the subset of your universal set. Same way, throwing a die is an event. And what are the outcomes? You know, the outcomes are 1, 2, 3, 4, 5, 6. Okay? So that is the definition of your event. Now, let's see various types of events. Various types of events. First is discrete and continuous events. Discrete and continuous events. What are discrete events? Events in discrete sample space. I already explained about discrete sample space. Okay. If the sample space is discrete, then the events are said to be discrete events. Suppose, what is the example? Tossing a coin is a discrete event because it gives only two outcomes, head and tail, discrete outcomes. So that is the reason this event is called discrete event. Same way, throwing a die. What about continuous? What about continuous events? Suppose, take one sample space like this. And let us take the event as selecting a number randomly in the given range. Randomly in the given range. Then, this is the sample space and the event is selecting a number randomly in the given range. It is a continuous event because in this range, selecting a number is very difficult and we can't find it actually because it consists of infinite range of values. Those type of events are called continuous events. Next, certain and impossible events. Certain and impossible events. What is meant by certain event? An event is said to be certain, then it always appears as outcome. Always appears as outcome if the event is certain. Suppose, same example, generally the probability concepts are well explained with the help of two examples simply. Tossing a coin, throwing a die. Okay, here also certain event. Suppose toss a coin. Getting head is definitely certain. Getting tail is definitely certain. Okay, but we may get head or we may get tail, but getting one element is certain. Those type of events are called certain events. Then what is impossible event? Impossible event which won't occur. Impossible event, the best example for impossible event is null set. Okay, it won't occur in any experiment. Experiment won't consist of, never it consists of no outcome. So that is the reason null set is called impossible event. Then we'll see mutually exclusive events. Mutually exclusive events. Two events of an experiment have no common elements. No common elements. Okay. So suppose take the events A and B. If these two are not having any common elements, then the two events are said to be mutually exclusive events. Then next is equally likely events. Equally likely events. In a given experiment, if one of the events in sample space does not depend on other event, if one event does not depend on other event, then those two events are called equally likely events. Okay, means performing one event is not affected by other event, or one outcome is not affected by any other one. Suppose, example, take your throwing a die. All the phases are equally likely events. All the phases. All the 6 phases are equally likely events. All the 6 phases. 1, 2, 3, 4, 5, 6. All are equally likely. Once if you throw a die, definitely there is a chance of either 1 or 2 or 3 or 4 or 5 or 6. So those type of events are called equally likely events. Even in the example of tossing a coin, getting head or tail, these two events are called equally likely events. Okay, then exhaustive events. All possible events in the sample space of a considered experiment. All the possible events in the sample space. Okay, then again, what is the example? Same, if you take the throwing a die, if you take the same example, there exists 6 exhaustive events. So when you throw a die, you're going to get either 1, 2, 3, 4, 5, 6 numbers as phases. So you're going to get 6 outcomes. So those are called exhaustive events. What are favorable events? Favorable events. Number of outcomes which are favorable to get the required event. Number of outcomes which are favorable to get the required event. Suppose, take your throwing a die concept. What are the outcomes? Outcomes are totally 1, 2, 3, 4, 5, 6. Let us suppose the required event as getting odd number. Then what are the favorable events? The favorable events are 1, 3, 5. How many number of favorable events are there? Okay. So this is called favorable event. Okay. I'll explain equality of events. Two events are said to be equal. Suppose take two events A and B. If the two events are said to be equal, if they have common elements, totally common elements, means you can write either A equal to B, or you can write A union B equal to A intersection B. Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.